My name is Zach. If you don't already know me, I'm a developer relations engineer at Protocol Labs, specifically within the FVM, Filecoin Virtual Machine team. And, today I'm going to talk to you about what the Filecoin Virtual Machine is, kind of the basics of Filecoin, and we'll go into some specific applications you can build on the FVM, specifically DataDAOs. Right, so the Filecoin master plan, if you're not familiar, step one is build the world's largest decentralized storage network, and that is already checked off. Step two, onboard and safeguard humanity's data, and I think this is a mission that goes on forever, right? We won't have all of humanity's data on Filecoin at any one time, but we want to get as close as we possibly can, right? And step three is bring compute to the data to enable web scale apps. And this is where the Filecoin virtual machine comes into play. Right? So the Filecoin virtual machine project delivers on-chain programmability to the Filecoin network. And we'll talk about what that means specifically here in a second. So some of the most common questions that we still continuously get and misconceptions we get is, what's the difference between Filecoin and IPFS? Where do they sit? How are the two related? A lot of people seem to know that they're interconnected. Filecoin and IPFS are actually two separate networks, right? You have IPFS. It's got its network of nodes and computers where you can pin data. And you have Filecoin, where we can think of it as layers, where we have a layer 0, which is Filecoin, the storage layer. This is the storage providers who are running the Filecoin nodes. Layer 1, you can kind of think of it like a 0.5 is really what I think about the FVM, because it's built into the node software. It's not like another chain or another compute environment plugging into Filecoin. It is in Filecoin. And you have the layer 2s, where you can program actual dApps on the Filecoin virtual machine. Right, so on IPFS, you can run your own node and or run a bunch of your own nodes and pin data to it. You can run nodes with the community, and if the community really likes a specific piece of data, they can run nodes and keep that data alive. Or you can run your own node and pay for a pinning service to keep data alive, right? So IPFS is all about getting data stored and retrieving it through its content identifier. But this does not give you guarantees that the data will stay up and live. For paying for a pinning service, this might introduce like a centralization vector into the dApp, which not all dApps want to accept, right? So this is where Filecoin comes in, right? So you have the storage provider network here at the bottom. They're all running their nodes. In the middle, you see the Filecoin blockchain. This is actually being run within the storage provider network here in each of the nodes. So this is kind of like a logical thing. And this is kind of acting as a middle layer between these storage providers and clients who want to store data with these storage providers, right? So a storage deal is made on chain, and this kind of crypto economically incentivize these storage providers to store data and gives clients a way to store data in this more decentralized environment. Right, and now to make things a little bit, add another layer of complexity, within this blockchain, being again run by all these storage providers, is the Filecoin virtual machine, right? Which allows compute to happen within the blockchain. And in this case, the Filecoin virtual machine is actually running the Ethereum virtual machine within it. And this allows us to make custom logic around storage field metadata for like storage and retrieval. You can make, for instance, DataDAOs, and we'll talk a lot more about the other types of applications you can build. So to get an idea of the actual architecture of what the Filecoin virtual machine looks like and the Filecoin node. So if we were to zoom in on one of those storage providers in the earlier slide and look at the software they're running, they'll run a Filecoin node. The most popular is a Lotus node. And within that, again, lives the FVM. And it is actually built using WASM time. So it's actually built with WASM. And within the FVM is a virtualized EVM, right? So kind of like how you can run a hypervisor on your computer. And if you're running a Windows, you could virtualize a Mac OS on there, or vice versa. If you're running Mac OS, you could virtualize Windows. Within these nodes, the WASM time is a virtualized Ethereum virtual machine, right? And this is the first runtime that is actually live. And in the future, you could have actual native, we call them native actors. You could program smart contracts and anything that compiles to WASM and deploy those to the chain, but that isn't live yet, right? In the future, there is a possibility of services such as Renew as a Service, interplanetary consensus subnets, native user-defined WASM actors, new foreign blockchain runtimes, right? So this is one of the advantages of this design paradigm, is that we don't have to settle for just a single runtime, right? If another virtual machine takes off in the Web3 space, and that's the one that most projects are building around, the FVM can be adapted to use a new foreign runtime, right? And it could even be a non-blockchain runtime, right? So for instance, the native WASM itself, and possibly any other runtime that you may find useful to run in a Web3 space. But since the EVM is the first runtime live, the FVM is compatible with all of your favorite EVM tools, and this is why the EVM was the first runtime to be virtualized in the FVM, right? So you can use Remix, you can use Hardhat, Foundry, MetaMask, all your favorite kind of tools that you're used to building with in the Web3 space. Slide. So why should you use FVM over all these other EVM compatible chains around? And the answer is storage deals, right? This is a unique feature that isn't available on any other chain. Because remember, Filecoin is based natively around getting data archivally stored, long-term storage. And with that comes this idea of storage deals, right? So what is a storage deal, right? So we talked about how the Filecoin blockchain kind of sits in between clients and storage providers actually store this large data. And on-chain, and this distinction is often confused, but on-chain, the data that we're storing with the storage providers does not live on-chain anyway, right? That'd be incredibly expensive. And that's the reason why blockchains tend not to store large data sets in the first place, right? Like NFT images are often stored on IPFS and increasingly so on Filecoin. And so Filecoin is around for what's actually stored on chain is the deal, right? So it's like the metadata of the data being stored with the storage providers, right? It's all of the data around how long that data is going to be stored, when it was created, who the client is, who the provider is, how big the piece size is, which is ultimately the data that's being stored with the storage provider. Is it verified on Phil Plus or not? And what are the fees being paid to that storage provider over the time, right? This is what governs the actual data being stored with the storage provider, right? And this is what crypto economically guarantees that data storage. So if every provider needs to put up stake, and with that stake, they need to provide proofs on chain that they actually have your data stored, right? So we call them proof of replication and proof of space-time. And if they do not provide these proofs, proof of space-time like every day, then they get slashed, right? And they do not get paid. So they have all these crypto economic incentives to keep your data stored, and if not, suffer the consequences. So again, just to make this distinction crystal clear, what isn't a storage deal? So what can't I access in the FVM? The actual data stored with storage providers, right? Again, that would be way too heavy, way too expensive to actually use in the FVM, and that's why Filecoin was created in the first place, to kind of create the infrastructure to maintain this data in a decentralized way, but not actually keep it all on chain. So we have the Filecoin virtual machine. We have these storage deals, which are native primitives to Filecoin. The EVM doesn't know about storage deals, though, right? It doesn't know about Filecoin, for that matter, right? It knows about Ethereum addresses. It knows about how much in the case of Ethereum, how much ETH. In the case of Filecoin, how much FIL is in every account. But it doesn't know what a storage deal is. Right. And so in conjunction with a team called Zondax, we created these Filecoin.solidity libraries, which is called Filecoin.sol. Right. And these act as abstraction layers between you, the Solidity dev, and the low level primitives that you need to access these storage deals in your dApps. Right. So if you were to go in there, you could go into contracts. You would find a contract called market.sol. And that provides some getter functions that you can use to get, live deals structures into your dApps and write logic around it. So again, storing data is really what Filecoin is all about. And so if you want to store data, you have three kind of paths you can take. Perhaps you don't need programmatic storage. You don't need to use a virtual machine for anything. You just need to get data stored. You can always store data like you always could on Filecoin outside of the Filecoin virtual machine, and just make a deal with a storage provider. And this can actually happen off chain. You can go to a storage provider marketplace, find one offering a good deal you want, or find one you think you can negotiate a deal parameter. And what you actually do is you sign that deal. That deal goes to the storage provider. They'll also check up on it and say, okay, this is actually good. They'll check that the data that you're actually storing with them hashes to that PCID, which represents the data. And if everything checks out, they'll call a method on chain with your signature, and the storage deal will become active, right? But perhaps you want to do this in a programmatic way, right? You want to somehow use the Filecoin virtual machine, for instance, making a DAO, like we'll see later, around these, like making storage deals, right? Well, if you actually want to store small data, which most hackathon participants do, and they're not like have these giant data sets, we actually recommend we go with what we call deal aggregation, right? Or using an aggregator. Big aggregator we recommend is Lighthouse.storage. They've been great at taking the latest features being available in the Filecoin virtual machine and integrating them in with their aggregator. And they'll abstract away the pain of making a deal for you, right? So you can call them through an SDK, or you can call them through a smart contract on chain, and they'll take your data, they'll prepare it to be stored, and then they'll aggregate it with a bunch of other people who want data to be stored, and they'll make a deal together on chain with a storage provider for you. Now, where this gets all ultra convenient, and what we really like about Lighthouse.storage and what they've done is they'll actually provide you what's called a proof of data inclusion, data segment inclusion, or PODSI, right? And remember, they're aggregating data among not just your data set, but they're combining it with all this other data, then making a deal, right? So how do you know what deal your data sits with? So you could possibly contact a storage provider yourself and get it back. Well, they'll provide you a proof of data inclusion on chain that says, hey, your data is aggregated in with this other data and stored with this storage provider, and here's the proof, right? So that's the advantage of using the data aggregator. But if you're feeling a little bit more savvy, you want to make deals yourself, you can use what we call direct deal making on chain with something called the client contract. And there's actually a deal making starter kit, and you'll have a link to that at the end of the presentation. But that allows you to make deals directly with Boost storage providers on chain. And you can do so by calling a function that emits an event that these Boost storage providers listen to. But this can be a lot more complicated, as you have to know the precise ways to make a deal. And if not, that deal might not go through, and that could be a whole round of troubleshooting, right? So, yep, we have those 3 paths. And again, for most people, I would really recommend the aggregator route, especially if you're going to be hacking in a hackathon. So what can the FVM solve? It can do what like many other Web3 virtual machines can do. It can do governance, tokenomics, DAO management. We're seeing DeFi projects launch, just traditional DAOs. But also we can build specific infrastructure around these storage deals, like repair workers that repair renew workers that will find deals that are faulty or about to expire and automatically renew them for you, and generate new storage deals, as I talked about in those 3 pathways through the client contract, right? So the FVM kind of supercharges the Filecoin ecosystem for storing data. And so you saw that, part of the label of the talk is DataDAOs. And if you're not familiar, a DAO stands for a decentralized autonomous organization. It really is just adding a governance process to smart contracts. So some smart contracts need things like upgradability and decision making that just can't be logicked away by ones and zeros in math. And in this case, we'll want to add a governance structure to our smart contracts to try to keep them as decentralized as possible, right? And this is kind of facetiously put in here about what is data. Data is a collection of discrete values, blah, 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 blah. I believe you all know what data is. But, data DAOs are combining these 2 things. And specifically, what I mean is, and what we mean at Protocol Labs is DAOs for storing data on Filecoin, right? You may hear the term used in other ways in other ecosystems, but when we're using it in Filecoin context, this is what we mean, right? So a DAO that governs data being stored with those storage providers. So as an example, my colleague Sarah came up with this idea of Biscuit DAO, right? The Biscuit DataDAO. It's a community of corgi owners that want to better understand their corgis. And so maybe you can think of Biscuit DAO as having ZK verified contributor to access the storage contracts, right? So we could have some kind of DID, decentralized identity, to verify who's doing what in the DAO. But these contributors, either way, they can upload data to the DAO throughout the week, and they can be minted tokens to reward corgi owners, right? And so this DAO could collect crowdfund money like Phil, or they can mint their own token for the DAO and reward people as they upload data to the Filecoin network, data that the DAO finds particularly useful. In this case, maybe health data on corgis, right? So as corgi owners participate in the DAO, they can get more tokens and further participate in DAO voting. And what can they do with this vote, right? So they can choose to train, for instance, AI with the data that's being stored in with the storage providers, right? There's a project called LilyPad being built on top of Filecoin, which also seamlessly is trying to have a bridge between Filecoin and heavy compute AI. So you could kind of combine these 2 things and train AI models based on the data the DAO is storing. The DAO could vote to access and control the data set that is off-chain for specific users. And of course, the DAO can vote on how to use the rest of the funds in the treasury, right? Maybe they want to get more data stored. Maybe they want to have access to DEXs and trade across currencies that they may find interesting, or fund these renew, repair, replicate deals I was talking about earlier, this infrastructure to keep the deals alive, right? So you can have this data that lives with storage providers, and the DAO can kind of perpetually fund that data to be stored permanently with their treasury. And in the end, you get healthier and happier corgis. Who doesn't love happy corgis? This little fellow looks pretty happy, if I do say so myself. And so I think, everyone kind of gets a happy end to the story. And while this is like a fun example, just to kind of make DataDAOs real, I see a lot of personal use cases. I see a lot of people coming in and doing with cool ideas like scientific data. There was a project that wanted to take like oceanographic data that they were collecting in university and storing it in and using a DAO to kind of decentralize ownership of this data. You can actually find an MVP repo of Biscuit DAO that I built for fun at this link. Check it out. Again, it's just a demo for you to kind of go through, see some of the scripts that have been made, see some of the SDKs that were used. Front end is on the way. But yeah, so you can, when you're brainstorming a data DAO, this can maybe give you something concrete to start off with, right? And again, I want to shout out to Lighthouse Aggregator, which I talked about, and they've really been building out some really cool stuff. They have really good docs. I highly suggest you check it out. And they take advantage of all the latest technologies, like that pod size you see here. Like, how do you upload your data and get a proof that your data has been uploaded on chain? Extremely easy to use, and keeping up to date with all the latest tech in the Filecoin ecosystem. And for something as more of a launching point, if you're thinking about building a data DAO, Biscuit DAO is just kind of a concrete example. We have a data DAO kit, which kind of has all of the building blocks that are like not opinionated, that are just kind of there to show you some important building blocks you may need to use with some scripts, right? So Open Zeppelin governor contract, ERC20 votes contract, all Open Zeppelin standards here ready for you to use and take advantage of. And for some more general FVM resources, you can check out this link tree, which has everything before, and links to the GitHub forums, docs, use case ideas, and all their community discussions you may find useful. So yeah, thank you for listening.